I would say first of all, do we have any comments about each other's papers? I have a brief one.
Yeah.
About Rubens. I was really interested in this relationship between discretion and sort of rule-based, I guess, exercise of just kind of operational judgment. And what struck me about this, and this is very significant for what I was thinking about in the paper, is that discretion, in some sense, is, I would argue, or at least in its roots, has a kind of moral texture, has a human texture, right? And so if we think about the origins of the word, it actually had something to do with moral prudence and sagacity and the exercise of discernment in a particular situation. And so for me, I think something that's interesting there is that it possibly could be a connecting point, right? Where discernment is where the human enters the AI-supported decision-making process. And it's also a necessary component which then eliminates the possibility for having morally justified autonomous decisions. So you see what I'm saying? So if we delimited AI as decision support as opposed to real exercise of autonomous decision-making, which the autonomous decision-making wouldn't have discernment, right? I mean, even though the claim is that there's this other.
I mean, the problem is, of course, that the discernment comes through. Like once you have a complex system, right?
Yeah.
Then you have then you have discernment, as you were saying, that's kind of embedded and like problematically embedded in the system at that point. And for both of you, I don't think you can answer this now, but one of the things I was particularly thinking about in your intentionality discussion is like the unintended consequences problem, which is a serious philosophical problem in the field that I work in, because we are always thinking as if like philosophy has a difficulty with path dependency, right? Like, so there is an intentionality within the parameters that you were putting on the system. But when you begin to operationalize it, at what, like, does it split off early on? You know, do the unintended consequences split off like immediately? And then you're like, but we had this great plan, so it's actually fine. So these are other questions, I think, for applied ethics that, to me, seem super interesting and difficult.
I guess if I could try and link to both talks. So I think an interesting link maybe to Alison's talk is to think about, well, the human in the loop in the examples I'm thinking of as like the welfare officer who's given a file with a risk assessment and then they apply some judgment. And then maybe they say to the person, well, yeah, if at the moment I wouldn't be giving you this, putting you up the housing register or whatever it might be. But if you do X, Y, and Z, then your score will go up or down, and therefore, so there's like interesting links between the application of discretion and gaming the system, which is, I guess, what the insurance company were worried about with the drone insurance. The drone operators saying, well, if I just go to the very edge of this boundary here, suddenly or if I change the weather provider, suddenly my premium goes down. So there are interesting links maybe between this like logic of consistency being just, and then edge cases and humans in the loop facilitating each other to do that kind of thing. A link maybe with your talk, David, is what one thing that's really interesting to me is this notion that machines can inherit not just the patterns of social life that the data from which the data that they're trained on is drawn, but also, in some sense, the intentionality. Is that what you're getting at?
I mean, in a sense, yes. And so I think that there is this moment of the creation of the algorithm, which is intentional, right? And then you've got release the mechanisms. Yeah. But then when we're actually using it, the intentionality is back.
It's inherited and then it's resurrected.
It has to be, yeah.
Right. And then, well, in that case, I can imagine if I'm putting myself in the position of the proponent of algorithmic decision making, it says, well, at some point along the chain there has to be some kind of human discernment, right? And if we're willing to accept that the human discernment can be inherited and resurrected later on, well, maybe it's okay because, you know, a human has been in the loop. It's just the loop isn't in the system. It's like in the training data. And I don't think I agree with that.
The loop is often in the training data as well.
Right,
and they're like, you know, and that's often where some of these questions, these unintended consequences can, you know, be, there are places that where they are opaquely visible, you know, the potential for things to kind of go not according, you know, to the plan of intentionality, you know, being present, disappearing and reappearing. There are places, I think, where it becomes like, you know, easier or harder to see along the way. But I feel like we should open to the floor. We talked a lot. I see one.
Yes, go ahead.
So about the intentionality and the tensions, as you mentioned before, with explainability. So it's like deep learning came as a solution for the problem of the feature engineering. So it's like we don't want anymore to give the features for the system saying these are the characteristics for this problem that are important. We want the system to decide to itself. And then it makes the algorithm more accurate because then the algorithms can use every data that we give and try to come with the best solution. So then there is a tension between explainability and accuracy. So like if a tool is diagnosing you to having cancer or not, do you like it to be understandable? And then you have like a good explanation for what you are receiving, even if it compromises the accuracy of the response of that, you know, because like I'm not using all the real important features that would be useful to diagnose you. So there is also a tension there.
Yeah. Should we get a couple questions and then respond to a few?
Sure.
Yeah.
Go ahead.
Is there a kind of presupposition then that must be actual data versus anonymized data versus synthetic data versus pseudonymized data? Because obviously the kind of intentionality that would come through on that might well be different, and also you couldn't then reflect it back into the social value or the moral standard that it came out with at the end without knowing that at the first case, if that makes sense.
Right, but I mean, I would quickly just say, in any production of any bits of material, data material, even if they're synthetic, the human hand is there, and so it really just goes to tracing it back to where is this coming from? What are the meanings and the values behind the production of this part of the system? So I think that it doesn't take the human also is involved in those situations in a deep sense. Yeah.
I think this gets to the first question as well, which is actually a question about trust. It's not really a question about system design, because you could approach the same question from a different perspective, and you could ask it, you know, from the vantage point of medical sociology, and you could ask a person how much you would like that they would prefer their doctor to tell them about the methods that are used at the moment to diagnose cancer, right? This is a parallel, and this is a way of understanding how much explanation a person might wish to have without telling them that a machine is that it is a machine that is being explained. And so there are also questions around like you don't have to know everything about all qualities of data. You might want to know which sorts of data are trusted. You may need to know what's in the training data. You may need to know about the context in which the system operates. And those might give you kind of proxies for assessing some of the things that you're looking at.
And if I could just add, Ruben and I Ruben's at ICO full-time, and then I'm helping with their explainability guidance now. And so what you were saying has been a kind of central topic, we had a citizens' juries where that exact kind of issue and question were posed to, you know, people who needed to think through sort of this relationship of accuracy and explainability, or accuracy and potential opacity. And I would just point out, it's really important to make a distinction between the context of using social and demographic data for the purposes of determining outcomes in society that face reasonable expectations based upon the social norms and relations that we have. We call that social and demographic data processing. And in that context, using neural nets is entirely unacceptable. Because in that context, we need to be able to determine in the feature space, are there proxies for discrimination? If there's too many features, the system will be opaque, and we can't guarantee, say, or confirm the fairness or the non-discriminatory character of the system. And so in those social and demographic data processing contexts, using neural nets is a very questionable thing to do. But when you have a high-dimensional feature space, say if you have radiomics, where you have like an MRI system that's using pixels from an MRI, where they have billions and billions of features that are being run through a neural net, and we don't really understand the insight, but it is insight. We can test that system in the same way we test pharmacological outputs, right? We can test it for safety. We might be able to test it for reliability. But do we actually need to be able to get into the semantics of it? Probably not, because do we really understand how aspirin works or paracetamol works? Probably not. So there's that thing to remember. Yes.
Hi. Sorry, yeah, I've got the microphone. Alison, again, what struck me in your presentation was the thing where they were prepared to show the variables, but the way, also what you were saying, neural networks work is that it's very hard to attribute, say, 35% of this decision, we can attribute that to the wind factor on this day or something like that. But I was interested to learn about if you'd come across any approaches that would, sort of from a technical perspective, that looks sort of promising to bring us close to that.
We experimented with matching. We experimented mostly with kind of scenarios that you could show to end users in very straightforward ways, which is a really small category of the things that you're interested in. And we didn't come up with very much. We came up with, you can sort of see like a trend, for example, in decisions of this type with, in this area. Like you could maybe model, reduce a certain number of features, and you could sort of show a model. But I'm not sure that is helpful, because we were concerned about whether that might be misleading, because of course there is no easy way to sort of say this amount was due to this. So we ran into a lot of difficulties with that in terms of explaining to end users in particular. I think what we also, when we moved on to federated learning, we also had a lot of other discussions that are similar to the ones that my colleagues have just talked about, which were really about where are the risk areas for using federated learning. So for some applications, it might be very effective to use federated learning. For example, if you want to have a model that allows you to more efficiently navigate on the screen of your own smartphone, but it may not be a desirable kind of learning system, for example, for learning how you wish your news feed to look. So there are also things that we looked at within the system design that were actually more promising. So not trying to explain how neural nets work when people get decisions, but actually explaining to people who are in the process of designing systems what the consequences are of applying different bits and pieces or different strategies of automated systems within a larger complex system. And that is, again, a kind of more social perspective on this, looking at the complex production culture of automated systems and looking at how they fit in, in each stage of that. And that's reflected, I think, also in the current literature that I've been reading, where it turns out that most explanations of machine learning systems are consumed by people who are designing systems, not by people at the end use, in the end use case.
Go ahead.
Okay. Ruben, you provoked a thought in me, and the thought was that you're going to base machine learning on data sets and sample data. And really, the algorithm and the data sets are really going to be created in the image of the creator. This, to me, would lead to what I would call cognitive bias in the machines, and you've introduced the notion of politics, which you know changes like a bellwether. So what I perceive is we could build machines here that would start the process of discrimination against people. And I remember a discriminatory process that occurred in America called the Community Reinvestment Act, which led to the crash of 2008, called redlining. Now, if we hand that, and that was made by humans. Now, if we hand that over to machines, I am really concerned about this cognitive bias, which could be exploited for political reasons as well.
I mean, yeah, it's absolutely a huge problem, and it's been documented in so many ways. And there are kind of different sources, right? So there's the source that you mentioned, which is discriminatory processes, structures in society, which mean that the variables you're observing are heavily influenced by those, so that many of the variables you'd want to use to predict are representative of those unjust social structures, right? So that's one source, and that's a worrying source. Another source, which is also worrying, is that simply by dint of being atypical, so when I say that, I mean simply by being the type of person who is less represented in some data, and that could be for discriminatory reasons, or it could just be that you're left-handed, for instance, right? We're not saying that any more left-handed people are discriminated against, but nevertheless, they're in a minority. And if you design a model that's fit to the majority, you will certainly perform worse on the minority. And so that's even without the injustice that the social injustice that we have in the world, ML will still produce those kinds of outcomes. And so it's kind of important to disentangle these different things. But and then the question is, well, once you've done that, what do you do about it? Do you want to change the data to make it look like how we would want the world to be, and thereby help us get to the world we want to get to, or do we do something else? So that's a big open question at the moment.
Got a question over here.
Yeah. Hi. This is to Alison. You combined the AI with kind of academic with design principles. So one other side is when you present to the end user using design principles as a presentation layer, you can also personalize it in terms of how you present. For example, you can use a color code for certain set of people, you can use a wording for certain people. Is this somehow embedded into the kind of thought process when you designed it, or it can be progressed towards it?
Yeah, I think there is a much larger space for thinking about design principles in relation to explanation than we explored in this very small project, because this was for the design team. This was a 3-week project. For us, it was longer because we are cheaper, it turns out, as academic researchers than professional designers. And I think one of the issues that it's not really an issue with the project. One of the limitations that we had, because the time was short, was that we used conventional design patterns. So sliders and graphs and the kinds of interface elements that you would normally see on a kind of mobile phone interface. And I really wanted to explore quite a lot more. We did experiment a little more with some other prototypes, but they were still within this general kind of visual, playing around with things on a small rectangular device. And I think that is a huge limitation and potentially a very big problem at the kind of, how do you engage with these explanatory processes that my colleagues are devising that are actually highly complex and which are social, interactional and relational. So I don't think that the best way to explain, for example, the nature of these decisions is through an individual interface to start with. I think we need to be much more creative in exploring how we can get to that.
Go ahead.
Hi, thank you so much for presenting your research this evening. This is a big question, so however you can answer it from all aspects. How do you explain randomness? So if we're, and I mean, obviously we can, from the 3 different perspectives. is just any thought on that would be.
Rupen can get that one.
I mean, I love this question. It's a really good question. We did some research where we had people. We had a set of decisions that had been made by an ML system, and we basically overlaid different kinds of explanations. And we asked people, do you think is this the right decision? Is it fair, etc. When we asked them to say, well, what would a fair decision be? One of the participants said, well, have you seen Batman, the movie Batman? There's a character called Harvey Dent who says that chaos is fair. Is that right? Is it the right character? Chaos is fair. So chaos is fair.
Yeah.
And that's the principle of lotteries, right? That's the principle of
And so many
things. It's a really interesting question. Why do people think chaos is fair, and why do they think it's unfair? And how can we hold both beliefs at the same
Even
time?
that's random.
Yeah, and I would just add to that, there is a dimension of morality in contingency, right? So it's called moral luck, right? And so the lottery of life, right, is fair in a sense to all. And
It is not just, however.
yes, that's true, baby. The point is that it's a good thing to try to take the value of randomness or moral luck and hold it against the value of predictiveness, because predictiveness as a social value is prevalent today. I mean, we recently had a stakeholder from one of the credit companies come and talk to us about their new neural net algorithm that has explainable characteristics. And the question was raised in the conversation, well, why is it that you need that extra kick in predictability, which might also discriminate against somebody? It's the value of predictiveness that at that point trumps our other moral values. And predictiveness isn't given. I mean, it's, as a value, it isn't a given value, and it's something we need to think about. It's good to have holes in certain algorithms. Regressions might not be a bad idea when those holes that allow people who might not have gotten an opportunity to get an opportunity and advance in life, right?
Absolutely. And from a communications perspective, how comfortable are people or individuals with this idea of randomness? How much do we want explained to us?
People do not actually understand randomness.
Yeah.
So the best sort of design story about this is random song playing. Yeah. So the order that if you have a song library and you click random, it is not actually random, because people do not like the actual random song generation because it plays songs in a row. Because sometimes it's randomly, the randomness says that the next song actually plays. And people don't believe that actually the next song playing on the album is a random or arrangement. So I think we also have a real problem because people don't understand in practice what randomness means. And so they might have a feeling or a cultural sensibility about randomness, which is derived from a pattern like the lottery. But the lottery is also not random because you have to buy a ticket. So, so this is and a lottery cannot be used, although it is a mental model for randomness, it is not truly randomness either. So I don't know, I think it's an excellent question. But I do want to say, that the sort of counterpoint of randomness should not be predictability. The counterpoint of randomness and chaos should, in fact, be justice.
That's a wonderful comment, actually, to end on, and a wonderful question to end on. I'm afraid we are at the end of our event. It's 7 o'clock, but thank you so much to our three excellent speakers.